everyone, this is Jyoti and in this lecture we are studying about one of the most important topic in the physics, that is about semiconductors. I said it is most important. Why it is most important? Why it is necessary to study about the semiconductors? Because these are the future for the technology and even in the present. Right? We use mobile phones, we use LED bulbs, we use LED lights, we use LED TVs, and we use computers, and we use solars, we use many electronic devices, right? So there, the major role is played by these semiconductors. Then, what do you mean by semiconductors? Semiconductors are the materials whose conductivity is in between those of conductors and insulator. Then what are these conductors, insulators and semiconductors? First, let us see the classification. In this lecture, I am going to give the classification based on two types. First one is based on conductivity. Okay? Classification based on conductivity. Classification based on conductivity. Okay. See here, conductor's conductivity is 10 raised to 7 per ohm per meter. It means conductors easily conduct the electricity, right? There is no resistance. When it comes to the semiconductor's conductivity is ranging from 10 raised to minus 6 to 10 raised to plus 6. See here, 10 raised to minus 6 to 10 raised to plus 6. Right? So, see here, 10 raised to minus 6 to 10 raised to plus 6, 0 in between, right? So, in this range, these semiconductors acts like a insulator, and in this range, 0 to 10 raised to plus 6 range, they will act like a conductors. Okay, in practical applications, that there is a beautiful application of these semiconductors in computers, right? So our computer reads binary language, that will only understand the binary language, that is 0 and 1. So see here, in this range it will act like a insulator, means that will not going to conduct. Okay, that will act like a insulator. In that case, it is in off state. Then off state is represented by 0, and in this range that will act like a conductor, means on state, that will be represented by 1. Only these two signals are read by the computer. So this is the beauty of this semiconductor. Now coming to the insulators. Insulators will be having the conductivity which is ranging from 10 raised to minus 20 to the 10 raised to minus 10 per ohm per meter. See the numbers. So there is a huge resistance. So they do not going to conduct the electricity. We have seen the classification based on conductivity. Now classification based on energy band. Okay, the term energy band, I have used the term energy band. Now what do you mean by energy band? Energy band, so if you say energy band, then we have to remember the structure of the atom. Okay, so we remember the structure of atom, right? So atom will be consisting of a nucleus at the center, and electrons are revolving around the atom. So like this, so this is the nucleus at the center, this is positive charge, and electrons are revolving. Electrons are revolving. Okay, electrons are revolving around the atom. See, this is the outermost cell, we call it as valence cell, right? See, so we know that this atom is having certain energy level. This atom is having certain energy level, this electrons also having certain energy level. Let us take some example. One is lithium. Lithium atomic number is 3. So it can be, the electronic configuration can be written as 1s2, 2s1. So this S is called as a energy level. Energy level. And 1 and 2, they are called as a sub energy levels. Okay, they are called as a sub energy level. And what do you mean by energy band? Before going to energy level is when we study about the energy level, that is sharp energy level. When we study about a single atom, we'll get a sharp energy level according to the electron. Okay, according to the electron. But in nature, we don't find any single atom. We find a bulk atom, right? Bulk molecule. So in that case, there are many atoms together. They form a material. In material, we'll be having a many atoms, such as lithium, 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 many atoms. So in the many atoms, the same energy level, they will overlap one another. They will form a band. They will form a band. That we call it as energy band. Okay, we got about energy band. Okay, we got to know about energy band, right? So, in case of conductors, the valence band and conduction band. In case of the conductors, the valence band and conduction band are overlapped. Means there is a easy flow of charge carriers. And in case of semiconductor, there is a finite energy band gap that is less than 3 electron volt. Eg is less than 3. Eg is less than 3 electron volts. Means a finite energy gap. So a finite amount of energy is required to transfer the electron from the valence band to conduction band, or holes from the valence band to conduction band. That is a less amount of energy which is required to transfer from valence band to conduction band. Like in case of silicon, we can, in case of germanium, it is 0.75 electron volt. Okay. In case of silicon, okay, there is 1.1 electron volt is required. And in case of germanium, 0.75 electron volt is required to jump the electron from conduction valence band to conduction band. Then they will become a conductors. And in case of insulator, that is the energy gap is more than 3 electron volt. So it is very hard to remove an electron, to jump the electron from valence band to conduction band. That is why this insulator do not conduct the electricity. We have studied the classifications of the about the conductors, semiconductors and insulator. And now we are going to study the classifications of the semiconductors. So semiconductors have been classified into two types, intrinsic and extrinsic semiconductor. And what do you mean by intrinsic semiconductors? Intrinsic, internally, they are the pure form of the semiconductor. They are the pure form of the semiconductor. Means elemental forms like silicon, germanium. It's a pure form. Silicon, it's a pure form. Germanium, it is mixed up with nothing. So that is a pure form. They are pure form of the semiconductor. They will conduct the electricity by thermal heating. Okay, by giving the thermal energy, they will conduct the electricity. Now coming to the extrinsic semiconductor. Extrinsic semiconductors means, so extrinsic semiconductors, here the word is external. Externally impurities are added to increase the conductivity. Increase the conductivity of the semiconductor. Those are called as extrinsic semiconductor. Then this extrinsic semiconductor is divided into N-type and P-type depending upon the type of impurity added. That I will explain. Okay, that I will explain. These extrinsic semiconductors are the impure form of the semiconductor. Extrinsic semiconductors have been divided into two types. That is These extrinsic semiconductors are being divided into two types. One is N type, one is P type. Right. So extrinsic, as I said, extrinsic means the external impurities are added. Depending upon the type of impurities are added, those extrinsic semiconductors have been divided into N type and P type. And what do you mean by N type? What do you mean by P type? Okay. So before going to this, so in the periodic table, we'll be having the semiconductors in 14th group, right? 14th group, that is silicon and germanium. Okay. To this, if we the valency is 4. Okay. This, let us take a silicon which is having a valency 4. Okay. We know that octet rule, right? Every element in the nature wants to be stable by following the octet rule. Means the valency should be 8. Then only it will be stable. So look at this silicon valency. It is 4, right? So that is the same amount of energy. There is a same amount of energy which is required to add the electron to become stable, and the same amount of energy which is required to remove the electron to become it stable, right? So it is 4, it is half of 8, right? It is half of 8. So that is why these act like a semiconductor. So coming to this N type and P type. What do you mean by N type? What do you mean by P type? So beside of this 14, here it is 15th group and here it is 13th group. In 13th group aluminium it is there, and 15th we take phosphorus. Right? This is the valency is 5 and here the valency is 3. So aluminum will be having valency 3. One hole is there. And for phosphorus it is 5. One extra electron is there. So if we add this impurity to the silicon, there is excess of electron. So the majority charge carrier here are electron. So this is N type. By adding pentavalent impurities to the silicon or germanium of the 14th group, tetravalent, will get N type of semiconductor. Here the pentavalent impurities are added. Impurities are added. Okay. And if we add a trivalent impurity, that is aluminium. Okay. That is aluminium which is having one less electron. So if we add trivalent impurities to the silicon, then there is a excess of holes. Holes means positive charge. So therefore that will become P type of semiconductor. Trivalent impurities are added. High valent impurities are added. So from this we got N type of semiconductors and P type of semiconductor. Until now, we have studied about the classifications related to conductors, semiconductors, insulators, and also we have studied about the classifications of the semiconductors, what do you mean by semiconductors, and the types of the semiconductors, intrinsic, extrinsic. In extrinsic, we have studied about the N type, P type semiconductors, right? So these are the basics related to the semiconductors. Now, we have studied about the basic theory related to semiconductors, right? Then, where we use these semiconductors, how to fabricate these semiconductors, that we study now. So, PN junction, about PN junction diode. See here I took P type of semiconductors and N type of semiconductor. When we combine these two types of semiconductor, there is a recombination takes place. Means the electron from the N type and holes from the P type, they will recombine and form a there is a recombination. Only some electrons and holes they will recombine and they will form a region called a depletion region because the charge get depleted. That is why it is called as a depletion region. Okay, this is called a depletion region and this is called as this junction will be called as a PN junction. Okay. So now we got about what is PM junction, what is depletion region, right? So now we come to the biasing. Biasing, what do you mean by biasing? It is simply the process where we are applying, we are giving the voltage, means we are giving the energy, means energy to the semiconductors to conduct the electricity. See here, in biasing we will be having two types. One is forward bias and one is reverse. Another one is reverse bias. In forward bias, what we are doing is we are simply connecting the positive terminal of the battery to the positive side and the negative terminal of the battery to the negative side. In that case, what happens is this the energy is given in such a way that this is pulling and the depletion region is reduced. Depletion region, length of the depletion region is reduced. So the current flow is easy. So that is what happens in forward bias. And in reverse bias, what we are doing is we are applying negative terminal of the battery to the positive terminal of the semiconductor and positive terminal is connected to negative terminal. That is reverse. Reverse voltage is applied. In that case, the reverse energy, reverse force is pulling. They are pulling like this. Okay. So the length of the depletion region is increased. The length of the depletion region increases means the they will act like an insulator. In this case, they will act like a conductor. In this case, they will act like an insulator. They do not conduct the electricity because it will act like a barrier. Depletion region acts like a barrier. So this is the main principle which is used in a rectifier. Rectifier which is one of the applications of the semiconductors that is used to transform the AC current into DC current. That works on the principle that when the semiconductor PN junction is forward bias, it will conduct. When it is reverse bias, it will do not conduct. Okay. Thank you.